Hi, my name is Nicholas Lewis, and I'm about to do a discussion on simple and fractional distillation or organic chemistry 211. Um, just basically talking about the basic concepts and all the chemical and physical aspects of the process itself. Hope you enjoy. Thank you. Distillation is the process by which a mixture is separated into its components, and those components are purified. In the crude oil industry, crude oil is heated up, and the components of that crude oil condense at certain temperatures. For example, kerosene, gasoline, and diesel. In another industry that utilizes the concept of distillation, in the alcohol industry, distillation is used to achieve various levels of purity in liquor. Um, the underlying concept behind distillation is that some molecules are more volatile than others, meaning that the intermolecular forces for these molecules are very weak, which in turn they have a very low boiling point when heat is applied. Um, in the lab, we were able to perform simple distillation and fractional distillation. Simple distillation again takes the idea of heating up a mixture. A mixture goes up a column. That vapor eventually get condensed, and the distillate is collected. However, it is not a pure distillate as what we would should expect. In fractional distillation, however, it has a additional part to it, and it's called a fractionating column or a distillation column. This distillation column has small beads. Um, when the vapor of the component that has a lower boiling point goes up the column, some of the vapor gets condensed and collected, while some of the vapor eventually get condensed on the beads. Um, Unlike simple distillation, which is a single cycle process, fractional distillation is a multi-cycle process. And over time, the purity of the distillate from a fractional distillation will be higher in purity, which makes fractional distillation more efficient if you're trying to achieve a higher level of purity of a certain compound. In the lab, we were able to separate ethanol from water using both fractional and simple distillation. Ethanol, as we know it, has a boiling point of 78 degrees Celsius. Water has a boiling point of 100 degrees Celsius. Um, at the same time, however, even though they might not be boiling at the same time, ethanol and water will be vaporizing at the same time. That's roughly around 78 degrees Celsius. That's because even though water is less volatile than ethanol and has a more stronger intermolecular force, hydrogen bonding, water is constantly evaporating. So in the vapor that's going up the column at around 78 degrees, there will be some water molecule that would eventually get condensed and collected. Um, you could never achieve total separation. I mean, that could be possible, but it will take a long time. That is because the mixture itself is a azeotropic mixture. That means that within that mixture, the the temperature of the mixture is lower than the actual temperature of water and the actual temperature of ethanol. Um, that is because the ratio of the compounds are close enough so that it won't go above, or that it won't go above what the actual compound is. As as you will see, for the simple distillation, the initial temperature was right around 78 degrees Celsius, and it kind of remained constant. However, for the fractional, it was lower than 78, and it was constant for about 8 mLs, very constant. That's because the ratio of ethanol to water was higher initially in the flask, and 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 over time this temperature gradually spiked up, meaning that the ratio of water to ethanol in the flask was more water than the flask in the ethanol. So, with that said, there will never be 100% pure ethanol separation, or you could never separate water from the ethanol. There will always be some water within the ethanol that's being collected as the distillate. Some areas of some avoidable errors can be to to collect more of the distillate. Some eventually spilled out because of the force of which it came off the condenser. Some unavoidable errors is that you just gotta not heat up the original flask too high.